speaker here on the stage already. He's probably a Guinness record holder for most consecutive PHP day attendances, or actually as a speaker probably, 15 times in a row since 2007.
26.
Yeah.
I did my first in 1999, maybe the first edition. There was no, was at Rome. After I joined here in Verona, the same hotel, the same password, Wi-Fi. So it's 2000. That's nice.
That's
you know.
nice. That's a piece of history.
Yeah.
So yeah, please give it a round of applause, resounding for Enrico Zimuel.
Thank you. Introduction. Told him that basically I'm very old. That's the.
Oh no, come on.
The summary of your introduction. Okay, that's fine. So, good morning, everyone. How do you feel? Great? Okay, so I'm Enrico Zimuel. I work at Elastic. I'm a principal software engineer, means I'm old, so the same. I started to code in 1996, professionally speaking. I work many years at Zend, so I was one of the co-authors of Zend framework. I did also some academic at UvA, from Amsterdam, more or less. I forgot my accent. I'm a core committee member of the PHP FIG. I did also a lot of presentation. Again, I'm quite old. I wrote some book. This is Italian. It's Sviluppare in PHP 7. I'm writing actually a new book about PHP 8, but I'm getting old, so I'm taking a lot of time to write it. So I hope, hopefully, it will be released before PHP 9. I did, actually I'm a professor, adjunct professor at the University of Turin, and also at ITS ECT Piemonte. That is a school, a specialization school after diploma. So basically it's 2 years after the diploma. And you get, very specialized course. For instance, I teach in a back-end developer. So how to become a back-end developer in 2 years. Very interesting experience. And also, last but not least, the co-founder of PHP user group of Torino, the city where I live. Okay, so today I would like to talk about OpenAPI. And first of all, who is using OpenAPI? Okay, quite a lot of people. And leverage the OpenAPI to build, code, and actually how to generate code. So how to automate code, because everyone is a good PHP developer, everyone is lazy. So we want to build something that produces code for us. That's the goal, the ultimate goal, I would say, of developer. So this is the summary of my presentation. I will go a briefly introduction to the OpenAPI specification, talking about PHP tools. So which kind of tools do we have at the moment to build stuff using OpenAPI, how to create a web API client, and I will show you some project that I manage in Elastic, for instance, Elastic-Search-php, that is the official client to connect to Elasticsearch to manage Elasticsearch, and also the Enterprise Search, that is another project of Elastic to provide Enterprise Search. Okay. So what is OpenAPI? Is a standard, is a specification about HTTP, basically. So you have to build an API. You can describe this API using this specification. So it's very interesting because it's programming language agnostic. So it's very, general purpose. Okay. Okay. Hope now it's working better. So it's programming language agnostic. And this is very interesting because the goal was to build a language to specify HTTP without any language in mind. So it's kind of a mix from human and machine. So that means you can read an OpenAPI like a human. Hopefully you will understand how it works. But most important is also for coding, for automation. So it's supposed to be easy to read and to consume in order to, for instance, create a web client in PHP or in any language. The main focus is RESTful API. So if you have something close to REST, even if it's not RESTful, and we can open a debate here, but I don't want to open it. So if you have something like REST, the OpenAPI is very good. If you don't have REST API, you can have some challenge to use OpenAPI. The latest version is the 3.10, and 1 year ago, more or less. Some story behind OpenAPI was a project by Swagger. In fact, was called the Swagger specification. And in 2016, they become a project under the OpenAPI initiative umbrella. That is, open source collaboration project under the Linux Foundation. So they moved into the Linux Foundation finally. You can use JSON or YAML in order to represent an OpenAPI specification. For code generation, for automation, I strongly suggest JSON. For human readability, YAML, but you have to pick up YAML 1.2 in order to cover all the feature of the OpenAPI. So if you do JSON, I think it's better. This is the official website. This is openapis.org. So OpenAPIs, the goal is to provide a standard for describing a web API. And usually, the goal is to generate documentation automatically. So if you have a specification in place of OpenAPI, there are a lot of tools, like the Swagger one. You basically can create on the fly the documentation for the API, and it's quite useful because the main goal of a web API is to write the documentation for developers, because the web API, the people that needs to use the web API are developers. So if you don't have a very nice documentation, developers starting to struggle to use it, So this is very, very important, because you can build an amazing web API, but if you have a messy documentation, make no sense, right? So this is very, very important. But not only in documentation, because if you have OpenAPI, you can easily build a client in top of this OpenAPI. And I will show you some example. And last but not least, if you are building a server side, so if you're building the web API from the server side, you can easily document the code itself using some annotation, and I will show you in a minute. So basically, the OpenAPI specification comes from the source code. So you can generate the OpenAPI specification from the source code and have it to generate the documentation and the web client. So it's very, very important, because in this way you do less work and everything is automated. That's the final goal of any modern developer, especially in web application. So the goal is to have annotation system for the server code, as I mentioned. This annotation can be used to generate the API documentation and also the client library, because we want to help other people to use our web API. Because, a web API is just a way to describe HTTP messages, but we know as a developer that this is not enough. We don't want to do manually build the HTTP request each time. It's too complicated. You have headers, you have body, you have serialization. It's very, very tedious process. If we have something like a client library that can simplify this process, we are happy. Okay, just a brief overview about the OpenAPI specification. These are the main objects, the root document object. As you can see, we have three required properties that are OpenAPI, info, and path. The other are optional, but of course, the other are important in order to describe the request and the response object itself. That's the most important part. Just a brief example. This is YAML because we are human, and because I needed space for the slide. In this example, we have an OpenAPI. As you can see, the beginning is the version, so 303 in this example. You have the info properties, where basically you describe what the API is. Here I also had the servers property, where you can specify the endpoint, the URL, where you have to use in order to submit the HTTP request. You can have multiple servers, because, for instance, you can have a staging for testing, one for production. You can have multiple endpoints for multiple APIs, so it's very open. And you have the path. So the path are the list of all the endpoints. In this example, we have just one, that is /users. And as you can see, we are describing the HTTP messages. So the first key is the get. So this describes if someone send a get against /users, this is the behavior. So the response, for instance, 200, the content type, the schema, and so on. So it's a way just to describe the path with the methods, with the payload for the body and the response in a human-readable way. The interesting part, as I mentioned, is the request and response body. Because if you think about HTTP has headers and body, basically. So the meat is inside the body. How you encode the body, how you get information back in the body. And OpenAPI gives you the possibility to specify a schema for the body. For instance, in this case, we are defining a response, 200, so successful response. The description is a user object. And as you can see, the content is an application JSON, because JSON is de facto standard for HTTP messaging nowadays. And the JSON is just an object, as you can see, type object, with two properties, ID and username. The ID is an integer, and in this case, the user ID. And the username is a string, and it's just the username. So as you can see, it's a very simple way to specify how the body is structured, the schema of the body. There is an interesting feature inside OpenAPI that is the reference, the $ref. Basically, you can separate the schema of your object, because usually when you build a web API, you can have multiple objects that you reuse in different APIs. So you don't want to copy and paste, because as we know, copy and paste is the devil of any good practice. So you can leverage this feature of OpenAPI. So the $ref stands for reference. It's like a pointer, basically. And you can say, okay, look, the response here, the body, is a schema, but the specification of the schema is under another properties of the OpenAPI that usually you use components/schemas. So that means this is just a reference. So that means inside the OpenAPI, there is another point where I described components/schema/user. This is the example where you have the components key, the schema, and the user. So the user basically here is specified in another point of your OpenAPI documentation. And this is just the copy and paste of the previous example. So this is just an object with two properties, ID and username. So again, this is very, very convenient. If you have a complex web API, you will love the reference, because you can reduce and optimize the specification. And this is actually very interesting from a code generator perspective. Because if you have these references, you can just read. Imagine that you have to build a schema for your body and response in PHP. So we are reading the OpenAPI, the file. We are just reading the components part, and we can build classes with user name, in this example, with this property on the fly. So you can build automatically a set of classes that represent the basement for building the request and the response. This is very, very interesting. Okay, let's jump to some more PHP example code tools. Okay, so in this section, I just give you some tools that you can leverage to work on OpenAPI in PHP. The first one is the swagger-php under the zircote namespace in Github. So it's a way to generate interactive OpenAPI for your PHP application using doctrine annotation. Just simple example here. As I say, we are using doctrine annotation, so this is kind of comment with the @ there is a special tag here that is @OA, OpenAPI. And as you can see here, we are basically miming the previous example. So we are describing, using this annotation system, how the OpenAPI should be generated. So for instance, I'm just giving the information here, the title, the version. Imagine that you put this comment before a function in PHP that represents the implementation of the /API/users endpoint. You can have the response. Of course, this is just a little example. You can imagine to have more structured comments. And if you do that, so if you are able to just annotate your code, so here we are talking about server-side code, of course, you can use this swagger-php to automatically generate the documentation of your web API. So you solve a very important and very tedious task. Because if you don't have this kind of tools and you have to do manually, I know a lot of people are doing it manually, it's impossible. You will spend a lot of time, apart if you, depending on the amount of endpoints, of course, that you are managing. But even if you have 5 endpoints, imagine that someone in your group is changing one line of code that changed the behavior of very little API with inner properties from, I don't know, float to int. So very, very, edge case. Even that, if you do manually, there are very, very good chance that you forgot to update the documentation, right? And if you do in the source code, because we are developers, so our, meat is the code. We don't want to write PDF, doc, or whatever, right? We want to use our IDE and write code. So if you do inside that system, you will be successful because everyone is updated and everyone is automatically updated and automatically generated. In this project, swagger-php, you can even leverage the phpA attributes. And this is very, very interesting because right now I just mentioned, annotation using comments, but this is not managed directly by PHP, as we know. So you need another library that read the source code, parse the file, and extract the information. If you are using PHP 8, we have attributes. That means the PHP itself can read this meta information, right? We don't need an extra library in order to parse the code. And this is very, very interesting because give you the possibility also to do it at runtime. There are very interesting projects and ideas coming out in the PHP community using the attributes. So this is for the future, I would say. It's a new area of research if you think about that. So it's not just, okay, we have a notation, okay, instead of doing slash star, we're doing hash and square brackets. That's not the point. The point is, with attributes, we have a new feature inside the language itself that we can leverage, even at runtime. And this is very, very interesting. Anyway, swagger-php is able to do this by attributes. So you can specify the previous example as an attribute. Of course, you need to use PHP 8. And I have to ask for my knowledge. Who is using PHP 8 at the moment in production? Okay, wow, quite good. A little bit surprised, to be honest. Who is using PHP 7? Who is both? Okay. Okay, so we want to generate the API documentation. How we can do that using Swagger? Very, very simple. 3 lines of code. We scan the project, the folder root. We specify the output, that is content type application YAML, and we render the YAML. That's it. 3 lines of code. If you use the Swagger UI, so the library that read the file, you can have very nice documentation for free in a very convenient way. This Swagger UI nowadays is very, very powerful because this is not just a nice CSS page, but inside you have also the try out button. So you can actually try the HTTP requests and see the response on the fly. And this is a huge improvement from a developer experience because it's not just, again, a static document. It's kind of a dynamic document with the possibility to execute the HTTP request and see the response on the fly. So very, very interesting. Another nice project that I found in my research is the OpenAPI PSR7 validator. So basically, this is a project under the PHP League umbrella. And it's a way to validate PSR7 messages against the OpenAPI specification. So imagine that you have just the OpenAPI specification, and you want to check, you want to build some tests in order to verify if your HTTP request is compliant, if your HTTP message is compliant with the OpenAPI specification. So you have just to basically use this library in order to digest the OpenAPI specification, and there is a validate function inside this library. You pass the PSR7 object, and that's it. You can have true or false. Example. Imagine that you have OpenAPI.json file. Here we are using the validator builder, that is a component of this library. We are reading from the JSON file, and we are getting a request validator. So this is an example for a static testing, in the sense that we have an OpenAPI specification, and we have also in memory a $request that is a PSR7 object. So if you have this, you have just to execute the validate function here, and you get a match, where match contains all the information, successful, not, why, blah, blah, blah. You can do the same with the response. So if you have in memory a $response PSR7, you can check if this object is compliant with the OpenAPI specification. So this is very, 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 very interesting for testing, because you don't have to do nothing. So basically, you just store the HTTP request and response. You serialize when you do, integration test, whatever you want to call it, in a file. You get back and you use this. So the HTTP test will run in a few seconds. Very, very interesting. this library is not just for static. You can even inject this library inside, for instance, a web API project. And this library is able to run at runtime. So you can validate even in an integration testing, if you do live, if you do for real the HTTP request. This can be used also in that case at runtime. So more interesting. So there are a lot of scenarios. I strongly suggest to have a look at this library. It's very, very nice. Another interesting feature that I used a lot, that we use a lot in Elastic for validate on the fly using GitHub action. So basically this is an action on GitHub. So you can just plug in your project that check if there are some OpenAPI specification in your project, if they are validate or not. So very simple. This is an example for a public repository. You have the jobs, just the name of the jobs. Here you have the information about the version that you want to use for the editor validate. And the last line is the definition file. So you can have one or more file that contains your OpenAPI specification. In this example in YAML. So basically each time you change your code, this action will check if the OpenAPI 2.0 YAML file is valid or not. And this is very useful because if you're starting to think about automation, if you have something that directly, when you do some change, give you an alert, oh, you break this OpenAPI, blah, 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 is a big plus. Again, the ultimate goal is to automate everything. Okay, another very, very nice library that I really enjoy to use it is the Nette PHP Generator. So this is a library to generate PHP code. It's completely object-oriented, so the architecture is very nice. And it supports also the latest feature of PHP 8.1, so very, very interesting. Last but not least, it's compliant to the PSR 12 standard. An example. Imagine that you have to create a class in PHP. This class is final. This class extends another class. This class implements an interface. You want to put some comments. That is the API. As you can see, very descriptive, very simple to use. Everything is object-oriented. You want to generate the class, just print the object itself. So there is a two-string implementation inside the class. The output is, as expected, PSR 12 compliant source code with all the information that you specify in the demo. So this can be okay. I can do using template. Why I need the Nette PHP, right? We have a lot of template engine in PHP. Why we need this kind of tool? Because this guarantee that the code is compliant with PSR 12. If you do manually, and I did, you will spend a lot of time, fixing spaces, fixing stuff, checking for the tab, because we want to generate clean code, right? So I strongly discourage you to use any template system to generate PHP code. So please use this library because it's huge plus, and you will benefit a lot. Okay, so now let's jump. I hope I convince you to use OpenAPI. I hope that I convince you to generate documentation from OpenAPI. Now it's the goal to, okay, let's build a client using OpenAPI. So a library in PHP that simplify the usage of my web API. So again, the goal is to generate an OpenAPI code, PHP code from an OpenAPI specification. We want to use PSR standards, not because I'm part of the PHP fig, but because PSR standards are very good for interoperability. Thanks to PSR standard, we can exchange library in the PHP community. So that's a very, very big, successful project, I would say. Even if someone doesn't like the interfaces, that's okay. We cannot be happy. Everyone cannot be happy. That's human, behavior. But it's very, very important to have standard in the PHP community. So if you never use PSR standard, again, I strongly encourage you to have a look because this is a big plus for everyone. We need to share our knowledge, and PSR standards is a way to share it. Anyway, talking about the goals of a web client, we want to use, of course, PSR 7 messages, because we need something to represent the message, the HTTP message. We don't want to use anymore $_server. Oh my God. We want to implement a client, so why not implement a PSR 18 client, HTTP client? Even because we are not really interested in the HTTP transport layer. We want to build something on top of another existing HTTP library. We don't want to rewrite Guzzle, right? Everyone wants to rewrite Guzzle? You want it? Okay. Good luck. So we want to leverage another HTTP client. So the idea is, okay, we build the web client, but we can inject the HTTP library as a dependency of this web API client. So everyone can choose any PSR 18 standard that he wants. That's the idea. Of course, we want to log, because everyone is logging, right? Right? Okay. This is very important, of course. And again, we have another standard for it. And we want to find a way to simplify the usage of the web API. For instance, we can say, okay, look, the endpoints are just functions of an object, of a class. So imagine that you have /API/users, I don't know. You have a user classes, and you have a function that is get user, for instance, right? So we want to find a way to simplify the usage of HTTP. Maybe that's it's straightforward. Just the name of the endpoint become the name of the function of a class, for instance. And last but not least, we want to simplify the serialization and the deserialization of the body, right? So we want to pass something like, I don't know, an object in memory that represents the information that we need to send using the web API, the HTTP message, but don't want to be low level. So we don't want to say, okay, this is the body, this is the content. I have to serialize using JSON encode, JSON decode, and stuff like that. We want something more, abstract. Okay, so the first things that we did in Elastic, when I joined Elastic, there was Elasticsearch PHP 6 version. So my goal was, okay, let's try to, and it was not using PSR 7, any PSR standard. I said, okay, look, I want to, refactor the code to be, more modern PHP. And I started to think how to do that. But when I joined, after 2 months, there was Elasticsearch 7 released, so I didn't have time to refactor, basically, because 2 months, I need to understand, first of all, what is Elastic, because previously to join Elastic, I was not an Elasticsearch expert. Right now, after 3 years, I'm not an expert at all, but I know a little bit more about Elasticsearch. Long story short, Elasticsearch came a few months ago, so I spent a lot of time to refactor this code to think how to change it. And the first thing that I did was, okay, let's move the transport in another library. So I want to just have a library for the HTTP transport and another library on top of this to abstract the schema for the request and the response. That was my first goal. And I did this elastic-transport-php. This is a public project. It's basically a wrapper of a PSR 18 client. So the elastic-transport-php itself has a dependency of a PSR 18 client. So you can inject inside this transport whatever library you want. And this is the general schema. So you have the transport on the left. As you can see, we have 3 dependencies, PSR 18, PSR 3 logger, and also a node pool. A node pool is a special interface that we build in Elastic because the Elasticsearch project itself is a distributed server. So there is this idea of cluster of nodes. There are some algorithm to connect to different nodes. I try to use the PHP htplug interfaces for that. But there was some specific needs, so that's why I propose a different interface. So these are the 3 dependencies, and this actually is the client has the elastic-transport-php as another dependency. So basically, imagine that you want to build a client in the case of Elastic. So the client itself has transport as a dependency in Composer. And of course, I can specify another PSR3 logger because we are logging 2 different objects here. One is the HTTP transfer. So imagine that this logger here is logging something like HTTP request and response, more or less like a web server log, something like that. This logger here is more, abstract because here I'm, for instance, logging. This is the API. This is the name. These are the parameters, and so on. I use this, for instance, in enterprise-search-php. That is a client library that I built using the OpenAPI specification. It supports PHP standard. It supports request types because in the OpenAPI specification of this enterprise project, we have the schema of the request. So I can build in memory the classes. And the response, because we don't have for all the endpoints the response, so I prefer to have a more general approach. So basically you can serialize the response as object, as array, as string, as you want, in order to consume in a different way. So this is an example. So basically, this is the enterprise search client. So you have to create a client. You specify the endpoint, the token, because this used some token in order to communicate with the server. I get the app search because this specific client has inside 3 different projects: enterprise search, app search, and workplace search. That are 3 projects of Elastic. So when you have the client, so this $app search here is the client. This is the create engine function. As you can see, it's just the name of the create engine API. It is a post with all the parameters, blah, 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 blah. In order to create, to send the information, as you can see, I'm building an object in memory because I have the schema of the OpenAPI. I'm just using a create engine on the request and the engine schema here. So this is very convenient because if you have type classes, you have autocompletion, right? In your IDE. When you start typing, this is create object requires a create object request. So everything is clear. You know what you are doing. You don't have to know in advance the body of the API. Everything is automatically, and it's a big, big plus. When you have the response here, for instance, $results is basically the deserialization of the body, the HTTP response, and you can read the properties of the object. Very simple. So if you have name, so this name is a JSON field inside the body request, but here, for me, is just a property of an object. I don't know the details. I'm hiddening all the information, all the HTTP specification here are not present. There is no post, there is no JSON, right? So it's very abstract. Okay, but imagine that you don't have an OpenAPI specification, right? So if you have it, everything is very simple, right? So no OpenAPI specification. The server API is a black box. Imagine that, okay, it's some hidden software that is running, we don't know. How we can try to leverage OpenAPI? Okay, first idea is, okay, I can log the request and the response from this black box. And I can store it, the HTTP request and the HTTP response, right? Using this, you can write a custom OpenAPI generator. So imagine that you build a script using the Nette PHP library that I mentioned before to read the HTTP request and response and try to create the OpenAPI specification. Because if you think carefully, the OpenAPI specification is just a way to describe the HTTP request and response. So this is doable. It's not very simple, but doable. So if you spend some time, you can do that. But there are a lot of nice tools out there. For instance, the Swagger Inspector. The Swagger Inspector is a tool where you pass the HTTP request and response and is able automatically to generate the OpenAPI. Wonderful. There is also another project, Akita. You can use it in order to do this. So even if you have a black box, you can do that. In fact, our black box was actually Elasticsearch. Because Elasticsearch is a huge project, very, very big. It's a distributed search engine. It's written in Java, 64K commit. So it's huge. If you go to the repository, it's incredible. Dual license. It contains more than 400 endpoints. A lot. The endpoints are not really RESTful in the sense that there are a lot of variants inside. Imagine just the search endpoint of Elasticsearch. You can search against, I don't know, 100 different use cases, parameter, fuzzy search, aggregation. If you never use Elasticsearch, the first time that you go to the documentation page, you say, oh, look, oh, wow, where I need to start. A lot of features. So it's very, very complicated to create an OpenAPI for this kind of use case. In fact, we have a internally YAML custom format that specify how the HTTP request is built. This is an example, but if you are interested, you can check it out the slide later. It is not so relevant. The client, very important. We don't need just to write client for PHP. We support Go, Java, JavaScript, .NET, Perl. By the way, I'm also the maintainer of Perl because I'm the oldest one in the companies. I wrote Perl many years ago, and they say, okay, you know Perl, so that's a job for you. Python, Ruby, Rust, these are all the libraries that we support directly. So there is at least one person in Elastic that is the maintainer of these languages. And we built this giant project. So the idea was, okay, let's run Elasticsearch using the unit test integration of Elasticsearch, and we grab the HTTP request and response. So we are collecting all this information, and there is another project here, this type tester, that basically grab this information, create on the fly in Node.js a schema. We use Node.js because JSON you can just assign to a variable in JavaScript, and that's it. And if you use TypeScript, you have the validation of the model in memory. It's very convenient. So we use these techniques in order to create this structure in memory, and after we basically serialize this into a file. You can read it in Java, in PHP, in Go, whatever, and we built the classes from it. So we built this, crazy project, but it's working very well. And this is actually an idea where you have a black box system. You want to, create the OpenAPI specification, and this is automatically. So each time you change the Elasticsearch code, this run every hour and produce the output. So we don't have to do nothing. Very cool. Promise I'm finishing the presentation. Elasticsearch-php, of course, we use this approach. The actually requests and response are coming. They are not yet in the client at the moment, even if we release Elasticsearch-php 8, because there was this problem here: ensure backward compatibility with 7. So I need to find a way to ensure that all the clients, and there are almost 70 million installation up there, so I don't want to break the code of you. So you are welcome. I spend a lot of time to think how I can do backward compatibility and offering a new feature. I found this way. So basically, I don't know if you are familiar with Elasticsearch-php 7, but everything is an associative array. You have the parameter, you pass this associative array, you get back associative array. So this is very familiar, this line, this version number. So basically when you call an API, you have this associative array as a response. You can just read the information. This is not familiar. I put another level, so you can read the object, the property as an object. But the interesting part is this one. $response is an associative array, an object, a string if you want, but also a PSR response, PSR7 response. So you can say, okay, $response get status code. So basically the response implements different interfaces, and the property of the object are the deserialization of the body response. This is kind of a idea trick that came out after a lot of discussion with the community and internally. In this way, we can give you the possibility to have a PSR7 object and at the same time the previous usage using associative array or whatever. And of course, we added a lot of as array, as object, as string, as book, depending on what you want. So in this way, I hope people will enjoy to move forward to Elasticsearch-php 8. In all this stuff, I also proposed a new tag in the PSR 19 that is @generated. And I think this is important because a lot of time when you generate some code and you put this code in GitHub and someone, I fix this file, okay, but this is generated. So you cannot fix the file because otherwise the next time, so if we have some way to specify using a standard that this file has been generated, like @generated, so I suggest each time you generate something, please use this tag. We are building also a GitHub action to prevent someone to send a pull request that contains a file with @generated. So automatically, if someone is changing some file that has been generated, the GitHub, the pull request fail. So we are happy because no one is breaking the code. So very simple. Please use it. Last but not least, when you generate the code, you can also add a lot of metadata information. And this is very, very important because otherwise doing this manually is a mess. So for instance, here we have aliases API for the Elasticsearch-php. As you can see, all this information here are extracted by the OpenAPI specification. I don't write nothing. And I cut a lot of, because, was very big, this metadata, so I didn't put everything on the slide. Okay, That's it. Thank you.